Just wait. I will open the PPT. Yes. Good morning, all of you. Okay, screen is visible. Okay, in previous lecture, what we have discussed, we have started the 6th chapter and we have taken the 2 lectures on stepper motor drives. We have taken the 2 lectures on stepper motor drives. Okay, what is stepper motor? What is stepper motor? Okay, and you can see here what are the construction of the stepper motor, what is the operating principle of the stepper motors, clear, how it will be operates, how the rotor will be rotates, clear. And next, types of the rotor circuit, types of the stators. Okay, next, stepper motor with converter circuit, stepper motor with converter circuit. Okay, what are the what is meant by unidirectional, bidirectional, unipolar or bipolar motors, bipolar excitations? All these things we have discussed in yesterday lectures. Okay, and also we have seen the advantages and what are the characteristics of the stepper motor, and what are the applications of the stepper motor. So all these things we have seen yesterday. So today we are going to see here stepper motor we have seen, and we are going to see the switch reluctance motor drives. Okay, so today we are going to see the switched reluctance motor drives and converter circuit. Okay, so switch reluctance motor drives. So what is switch reluctance motor? Okay, so what is the this switch reluctance motor is same as the brushless DC motor. There is no difference, but only difference is we are using the permanent magnets in the rotor circuit. We are using the permanent magnets in the rotor circuit, but in the case of switch reluctance motor, so we are not using any permanent magnets in the rotor circuit. So just we are designing the rotor in order to make a poles, in order to form a poles. Okay, we are going to design the rotor circuit that may be a steel material, laminated steel material, or iron core. So that is the rotor material has been designed in order to form a poles. Means here we are not using any extra electromagnets. Here we are not using any extra electromagnet. That is a small difference. Remaining the same, the operating principle and construction is same as a brushless DC motor. The operating principle and construction is same as the brushless DC motor. The switch reluctance motor drive is considered to be an attractive candidate for the variable speed motor drives due to its low cost, simple construction, reliable converter topology, high efficiency over a wide speed range, okay, simple in control. So means the switch reluctance motor is very simple than the other motors like brushless DC motors. Okay, we can control the speed of the switch reluctance motor. We can easily control using the power electronic converter circuit. And next, it is giving the high efficiency. Also, it can be used in the high speed applications because we are not using any electromagnets. Okay, so in the case of brushless DC motor, we can see here. In the case of brushless DC motor, for example, surface mounted brushless DC motor. Okay, surface mounted brushless DC motor. Surface mounted brushless DC motor में क्या होता है? So we are placing the permanent magnets on the surface of the rotor circuit. Surface of the rotor circuit. Like this. We are mounting magnets on the surface of the rotor circuit. But in the case of whenever this motor is using the high speed applications, okay, if this motor is using in high speed applications, then what will happening? When the rotor is rotated with a very high speed, then there is a chance to fly these magnets. Okay, ये magnets क्या होता है? Remove होने के chances है. Remove होने के chances रहता है. Okay, there is a chance to fly. Okay, there is a chance to remove these magnets from the rotor circuits. Okay, so that's why surface mounted brushless DC motors cannot be used in the high speed applications due to because there is a chance to fly the magnets from the rotor circuit. Separate होने के chances है. Okay, that's why we cannot use in the high speed applications in that is the brushless DC motor, but switch reluctance motor we can use in the high speed applications. Okay, so see the what is the construction of this switch reluctance motor. The stator windings are connected in series with the upper and lower switches of the inverter. Okay, and this topology can prevent the shoot through the fault that exists in the induction and permanent motors drive inverter. So here you can see the drive. I will show the diagram of this switch reluctance motor. Clear? Okay, a conventional switched reluctance motor drive system consisting of the switch reluctance motor, power inverter, sensors such as voltage sensors, current sensors, and position sensors, and control circuitry such as the DSP controller and its peripherals. Okay, so here you can see the diagram. Okay, this is the simple circuit diagram of the switched reluctance motor drive. This is the simple circuit diagram of the switched reluctance motor drive. Okay, so this it is having the switch reluctance motor. Okay, it is having the stator and rotor. Okay, stator is having the poles and rotor is also having the poles. Okay, but this is not made by the permanent magnets. Okay, this is made by the cast iron or laminated steel. Okay, this has been designed in order to form the poles, in order to form the teeth or poles. Okay, and it is having the converter circuit. It is having the converter circuit. Clear? And this converter circuit is having the switches, and we are using the DC supply. Okay, instead of this DC supply, also we can use as a battery also, no problem. So see here, this is and also it is having the voltage sensors, current sensors. Okay, in order to measure the voltage and current. Okay, the basic magnetic structure, the switch reluctance motor has silent poles on both stator and rotor. Okay, it has a concentrated winding on the stator and no winding on the permanent magnet, no winding on the rotor circuit. No winding on the rotor circuit. Okay, there are several configurations for switch reluctance depending on the number and size of the rotor and stator poles. Okay, the configuration may be 8 by 6. Okay, 6 by 4. Okay, 8 by 6 and 6 by 4 is nothing but, okay, so 8 by 6 means 8 poles are the stator and 6 are the rotor. 6 poles are the rotor. Okay, for example, what is the this type of motor? 6 by 4. Okay, 1, 2, 3, 4, 5, 6. Okay, stator poles is 6, and what will be the rotors? 1, 2, 3, 4. 6 by 4 switch reluctance motor. Okay, in the case of this one, 1, 2, 3, 4, 5, 6, 7, 8. 8 and 6. 1, 2, 3, 4, 5, 6 rotor. 8 by 6 switch reluctance motor. Okay, so the name is given depends upon the construction of the switch reluctance motor. 4 by 6, sorry, 6 by 4, 8 by 6, like this. Okay, so there here you can see the switch reluctance motor drive systems. Drive is nothing but the drive is designed by using the electric motor and power electronic converter and electrical supply. This is called as a drive. So here electrical energy input, it is act as a source. Okay, electrical supply, either it may be a DC or either it may be a AC. Okay, so this electrical energy input is given to the power and converter circuit. The electrical energy is given to the power converter circuit, and this power converter is produce the output and is generated the output as is given to the output to the switch reluctance motor, is given to the switch reluctance motor. Okay, and this switch reluctance motor is connected to the load is mechanically. Okay, this switch reluctance motor is connected to the load mechanically, it is not an electrical. So here this power converter and electrical energy is connected to the electrically, and this power converter and switch reluctance motor is also connected to the electrically. And we are using the current sensors, position sensors, and also we can use the voltage sensors also. Okay, these current sensors and position sensor of the rotor circuit is used to give the signals. What is the, what will be the, how much current is flowing through the motor. Okay, how much voltage is generated by the motor, or how much voltage is getting the motor. Okay, all this current sensor and voltage sensor is sensing the voltage and current signals. And also we are using the one hall sensor or position sensor. Okay, this position sensor the will identify the information of the position of the rotor circuit. Okay, why we are using the position sensor here? These position sensors are always monitoring the position of the rotor circuit. Okay, at this time what will be the position of the rotor circuit. Okay, and this position information of the rotor circuit is given to the controller. Okay, this controller will be operates, and accordingly it generate the signals to the power electronic converter. Okay, which switch should be turn on, which switch should be turn off. Accordingly the power will be generated, accordingly the switch reluctance motor speed is also controlled, and it will be rotates like that. So this is the simple block diagram of the switch reluctance motor drive closed loop system. But in the case of yesterday we have discussed the stepper motor. So stepper motor is an open loop system. It is not necessary to design the closed loop systems. Okay, please remember that point. So stepper motor is a operated with a open loop system. It is not design. It is not necessary to design the closed loop system. It is not necessary to design the closed loop system. Clear? So next, switch reluctance motor construction. The construction of the switch reluctance motor you can see here. Okay, this motor includes the 6 stator poles as well as 4 rotor poles. Okay, the design of the stator can be done using the silicon steel stampings inside the projected poles. Okay, the poles are in the stator are either an odd number or even number. Okay, most of the electrical motors have an even number of poles within the stator which have the field coils. Means what we can say here, we are using the silicon steel for the stator. Okay, we are cutting this silicon steel like this in order to make the poles like this. Okay, okay, in order to make the poles like this. Okay, so in these slots we are placing the winding. In these slots we are placing the winding. In these slots we are placing the winding like this. Okay, or also we can wound the coils like this stator. Clear? So mostly the stator poles are maybe a odd number or even number. Odd number, even number की बोलते हैं तुम अपन, maybe a 3 pole motor, maybe a 4 pole motor, maybe a 5 pole motor, or maybe 6 pole stator, 6 stator pole motor like this. But mostly we are going to design the even poles. Okay, 4 or 6 or 8 or 10 or 12 and so on, etc. Okay, it depends upon the number of windings we are using and number of phases from the supply. Okay, so mostly we are going to design the even number of poles in the stator circuit. Okay, so when the poles are opposite, then the field coils will be concentrated in series or will be connected in series. So their magnetomotive forces are additive, which are called phase winding. A set of coils or single coil can compromise phase windings. Each winding can be connected to the motor terminals, and these are properly connected toward the output terminals of the switched circuit of the power semiconductor. The input of this is a DC supply. So here you can see here from this diagram, input is the DC supply. Input is the DC supply. Input is the DC supply, and if this DC supply is given to the inverter circuit, this DC supply is given to the inverter circuit. Okay, and the output of this inverter is properly connected to the each phase of the stator winding. Okay, the each phase of the or output of the inverter or output of this power electronic converter circuit is connected to the each phase of the stator winding. Each phase of the stator winding. Okay, next. So already we have seen the this is the maybe a 6x4 type switch reluctance motor, and 6x4 switch type reluctance motors. Okay, so what is the operating and principle of the switch reluctance motor? What is the working of the switch reluctance motor? Okay, the operating of the switch reluctance motor can be done through the switching currents within the stator windings of the motor by making changes within the magnetic circuit. This circuit can be formed through the stator as well as the rotor of the motor. Okay, the stator of this motor include the windings that are related to the brushless DC motor. However, the design of the rotor can be done with a steel that it is turned into the silent poles without magnets or windings. Once the poles of the stator One of the poles of the stator and rotor are out of position, then the magnetic circuit among them includes high reluctance. Okay, when the pairs of the poles, I will explain you, just to listen. Just listen, I will explain you point to point. So when the pairs of the poles in the stator are switched, the rotor switches to connect through the activated stator poles to reduce the reluctance of the circuit. So when the stator poles are switched, then they should be exactly timed to make the sure that it happens, because the rotor pole is moving toward the connect the activated stator poles. What we can say here, the operating and principle of the brushless DC motor and the operating principle of the switched reluctance motor is same as it is. Only difference is, in the case of brushless DC motor, We are using the permanent magnets in the rotor circuit. We are using the permanent magnets in the rotor circuit. But in the case of switch reluctance motor, we are using the steel material or iron material. And this steel material or iron material has been designed, has been cutting in order to form a teeth or poles. That is the small difference. And remaining operating and principle of the stepper motor and switch reluctance motor is same. Clear? So next, so see here how this motor will be operates. How this motor will be operates. Let it be here. How many stator windings are there? A, B, C, D, and A dash, B dash, C dash, and D dash. Okay. Total 4 phases and 8 coils are there. 4 phases and 8 coils means one is the entering coil and another one the current exiting coil. Okay. So what that we can say, if the current entering in through this coil and current through exiting through this coil. Okay, when the current is entering through this coil, it will form as a north pole, and current is entering through this coil, it will form as a south pole. Okay, these two coils are connected in series. Okay, this coil is wounded on the A pole like this. Okay, and current is exits through the A dash coil like this, and this it is goes to the where it is connected like this, and the A coil is connected to like, okay, this is the one closed circuit. This is the one closed circuit. Okay, so but what is the rotor position here? Okay, rotor is position, the second pole is exactly at the C stator pole. Okay, this is exactly at the C of the stator poles. Clear? So now if you want to rotate the, now if you want to rotate the, now if you want to rotate the rotor in this direction, in clockwise direction, so what we have to do? Which coil should be energized? Can anybody tell? Which coil should be energized in order to move this rotor in clockwise direction? Now the rotor position is at this position. Okay, so which coil should be energized? Which coil should be energized? Okay, for example, at first point, if the A coil is energized, then what will happening? If A coil is energized, then what will happening? A coil energize करने के लिए, in order to supply the current for the A coil, so which switches should be closed? कौन सा switch को close करना पड़ेगा अपन को? Here we are having the 8 switches: SA1, SB1, SC1, SD1, SA2, SB2, SC2, SD2. 8 switches है. कौन सा switch को turn on करना पड़ेगा if you want to exit the A pole of the stator winding? If you want to energize the A coil of the stator of the switch reluctance motor, so which switch should be closed? Current flow होना चाहिए इसका through. Current flow होना चाहिए ना? Yes. Okay, in order to flow the current through this coil, A coil, okay, the positive terminal is connected, the battery or positive terminal is connected like this, and the SA1 should be closed. And the current will be flow through this circuit. Okay, the current will be flow through this circuit and it will flow through this coil. Okay, and the current will be exit through this coil, through the A dash coil. Next, where it is connected? Here it is connected. So which switch should be closed now? Now which switch should be closed? SA2 should be closed. Yes, exactly. SAT should be closed. Clear? When the SAT should be closed means when the SA1 and SA2 switches are turned on, then the current is flowing from positive terminal to the positive terminal of the supply through the SA1, through the A coil, and then A dash coil, and then it will comes to the SA2, and then it will comes to the SA2, and the current is flows to the negative terminal of the supply. Negative terminal of the supply. Clear? This is the path for flowing the current. But यही switches turn on करने के लिए तो कैसे मालूम पड़ेगा अपन को यही switch turn on करना. Okay, the whatever we are using the position sensors here, whatever we are using the position sensors. Okay, so this position sensor will identify the position of the rotor circuit. Okay, will identify the position of the rotor circuit. For example, the 3 and 3 dash poles of the rotor circuit of the step switch reluctance motor is like this. Okay, half of the part is near the D dash pole and remaining half of the part is out of the stator pole. This one. So in order to move this 3 dash rotor in this direction, so this coil should be excited and it will be formed as a north pole, and it should be formed as a north pole. Okay, and it will act as a south pole here. It will act as a south pole. Clear? So if it is a south pole, definitely it will act as the third pole of the rotor is it will act as a north pole. And if it is acting as the stator pole of the A coil is formed as a north pole, then A dash coil should be formed as a south pole. A dash coil should be make as a south pole. It is clear? So means, for example, this is the coil A and this is the A dash coil. This is the A dash coil. So if the current is entering through this coil, it will act as a north pole. If the current is exiting through this coil, it will act as a south pole. Obviously, clear? So what will happen when this coil is excited, it will act as it will form as a north pole, and this north pole of the stator and the south pole of the rotor will be attracted and it will move toward this direction. It will move towards this direction, and here the south pole of the stator, okay, by flowing or by doing the excitation through this coil, it will form as a south pole. It will form as a south pole, and this rotor pole is acting as a north pole. Okay, this north and south pole will be attracted towards here. Okay, and it will rotate like this. It is clear? So this will rotate like this. This will rotate. Whenever this 3 and 3 dash poles coming to A and A dash stator poles, okay, the reluctance of this the reluctance is going to be decreased. Okay, the reluctance is going to be decreased means the rotor poles are aligned with the magnetic field of the stator, okay, which is produced by the stator windings. The rotor poles are aligned with the magnetic field which is produced by the stator poles A and A dash. Clear? Now again the position sensor will identify the position of the rotor circuit, and again the B coil should be excited. Okay, so this rotor position sensor will give the information to the DSP controller. This position sensor will give the information to the DSP controller, and this DSP controller, what it will do, this DSP controller will turn off the switches SA1 and SA2, will turn off the switches. SA1 को SA2 को ऑफ करेगा and B coil को excitement करने का now the B coil should be excited. Okay, the B coil should be energized. So in order to make the energization of this B coils, which switches should be closed? So now you see the B coil is connected to the this phase, and the current is flowing through this coil, and the B dash coil, the B dash coil is connected to the, कहाँ पे connected है? Can you tell where it is connected? B dash coil. SB2. Okay, B coil is connected to the SB1 and B dash coil is connected to the SB2. Clear? Okay, it is clear. So in order to do the excitation for the B and B dash coils, in order to give the excitation for the B and B dash coils, so the DSP controller will send the signals for the SB1 and SB2. Will send the signal for the SB1 and SB2. Okay, गेट पल्सेस जनरेट करना चाहिए और ये स्विचेस क्लोज होना चाहिए. SB1 क्लोज होना चाहिए, SB2 क्लोज होना चाहिए. Okay, then only the current is flowing through the B and B dash coil. Then only these coils will be excited and it will form as a north pole and south pole. Then only it can attract the rotor poles. Then only it can attract the rotor poles. Okay, so now this, see the closed path, positive terminal of the supply voltage. The current is flowing through the SB1. Okay, SB1 is closed now. Okay, this current is flowing through the B coil and it will form as a north pole, and it will form as a north pole. Okay, and the current is exiting through the B dash coil and it will form as a south pole, and it will form as a south pole. Clear? Next, the current is leaving through this B dash coil and the current flowing through this circuit, and current is flowing through this SB2 and flowing through this circuit and negative terminal of the supply voltage. Because this is the closed path of the closed path for flowing the current when the B coil is excited, when the B coil is energized. Clear? So whenever this coil is energized, whenever this coil is energized, it will form as a north pole, and the rotor pole, that is the 2 and sorry, this is the 2 nahi, 1 and 1 dash. This is the 1 and 1 dash. Okay, it will act as a south pole and it will act as a north pole. Okay, so here it will attract it toward this one. Okay, the north pole of the stator and south pole of the south pole of the rotor will be attracted, and here at B dash coil, the stator pole is act as a south pole. Okay, and the rotor pole is act as a north pole. These two will be attracted to each other. Clear? So the rotor again rotates in this direction. Sorry. Again rotates in this direction. Like this. Okay, again when the rotor rotates and the rotor position comes like this, again it will the position of the rotor circuit will be identified. The position of the rotor circuit will be identified, and this the position of the rotor circuit is given to the DSP controller, and this DSP controller will turn off the switches which are connected in previous case SB1 SB2 turn on हुआ, उसका ऑफ करना है. तो नेक्स्ट कौन सा कॉल के एग्जाइटमेंट करना है? सी कॉल के एग्जाइटमेंट करना, तो SC1 को SCT को क्लोज करना है, SC1 को SC2 को क्लोज करने का. Now the C coil is excited. Okay, so when the C coil is excited, then what will happening? Again the rotor will be rotates like this. Again the rotor will be rotates like this. Like this. Okay, like this same way, A coil should be excited, B coil should be excited, C coil should be excited, D coil should be excited. Okay, and again A dash, B dash, C dash, D dash. So the rotor will be rotate like this. The rotor will be rotate like this. It is clear. So in order to make the rotation of this rotor circuit, we should use the material which is having the magnetic circuit, okay, which is having the magnetic property. Iron is also having the magnetic property, and steel is also having the magnetic property. Okay, if this rotor circuit is not having the, if this rotor circuit is not having the magnetic property, so then it will not rotate, then it will not be rotate. Okay, please remember that point. So like this way, the switch, this is the operating and principle of the switch reluctance motor drive. So why we are calling it as a switch reluctance motor drive? Because the switch reluctance motor is operated through the inverter, and drive is nothing but source, drive is nothing but source, electrical motor, sorry, source and power electronic converter, source, power electronic converter, power electronic converter, and then motor, then motor. Okay, this is the combination of the electrical motor, power electronic converter, and electrical source is called as the drive. Is called as the drive. So here also same, when we are having the energy source, okay, and power electronic converter, that is the inverter, okay, and electrical motor. So the combination of these electric switch reluctance motor and inverter and electric energy source can be called as a switched reluctance motor drive. Can be called as a switched reluctance motor drive. Clear? So this is the operating principle of the switch reluctance motor. We can go through these points. Okay. So go to the, what are the switch reluctance motor characteristics? The characteristics of the switch reluctance motor include the following. The kind of reluctance motor is a single phase or three phase. Okay, maybe it may be a single phase and three phase. Speed control of this motor is simple. Okay, the speed control of this motor is simple. Okay, due to the less magnetization property. Okay, so the triggering circuit can be changed to get the high speed. Okay, whatever we are giving the triggering circuit, okay, whatever we are doing the excitation for the stator coils using the triggering circuit in the inverter circuit, by giving the gate pulses in the inverter circuit, okay, we can increase the speed of the motor. Okay, it operates with the DC supply once used in an inverter. Okay, if we are using the inverter, it can be operated with the DC supply also. It can be operated with the DC supply also, but for that we need to use the inverter. Clear? So once the firing angle of any switching device can be changed, then different speeds can be achieved. So obviously the gate pulses, the phase sequence of the gate pulses, if the gate pulses sequence are changes, means the firing angle changes. Obviously the voltage is also changes, the output power is also changes. We have whatever we are getting from the inverter. Okay, if the voltage changes, the speed is also changes. The speed is also changes. It is clear. So the control of one phase independent of the other two phases, means if we are using the multiple phases, more than one phases, so one at a time we can control the one phase. Okay, so we no need to dependent on the other phases. It is independent of the other two phases. Okay, because at a time only one coil is going to be energized. At a time only one coil is going to be energized. Either maybe A dash or B dash or C dash or D dash, whatever. Okay, so these are the this unutilized energy fed to the motor can be retrieved by using the feedback diodes. Okay, this improves the efficiency. So means here what we can say, we are using the diodes here. We are using the diodes here. So these diodes can be used as a feedback diodes. Okay, these diodes here can be used as a freewheeling diodes. Okay, by using these freewheeling diodes, whatever the energy is wasted, okay, whatever the energy is stored in the inductance, that energy can be reutilized and it can be given to the main supply. Means reutilize कर सकते हैं अपन. Next, advantages of these switch reluctance motors. Okay, so these motors are very simple, and the rotor in this motor are extremely strong. Okay, so obviously because we are using the iron material or magnetic iron or cast steel iron, obviously to be the rotor circuit is very strong compared with the brushless DC motor. These motors are applicable for the high speed applications because we are not using the permanent magnets. Okay, in the case of we are using the permanent magnets in the brushless DC motor, if in case we are rotating a high speed, there is a chance to remove the magnets from the rotor circuit. Rotor circuits are separate on a chances of magnets. Okay, because we are placing on the surface of the rotor circuit. So in high speed, we cannot use the brushless DC motor. Okay, but in the case of switch reluctance motor, this is not possible in the switch reluctance motor. So there is no chance to remove the magnets in the rotor from the rotor circuit because magnets is present nahi, तो remove होने के chances ही नहीं ना. So that's why we can use this switch reluctance motors in high speed applications. Okay, so to achieve the variable voltage and variable frequency is somewhat simpler than the other motors. Okay, this motor does not use any additional ventilation system in the stator as well as rotor slots. Is projected so that airflow can be maintained among the slots. Okay, so some motors is need some ventilation in order for cooling purpose. Okay, so this cooling purpose or ventilation is no need in the switch reluctance motor because we are not using any winding in the rotor slots. We are not using any winding in the rotor circuit. It is clear. So they are less expensive because of the non-existence of the permanent magnets. In the case of brushless DC motor, we are using the permanent magnets. Okay, even in that also, if we are using the rare earth magnets, that cost of the rare earth magnets are very high. So obviously the cost of the switch reluctance motor is increased, but we are not using any magnets in the rotor circuit here, switch reluctance motor. So obviously the cost of the switch reluctance motor is somewhat less than the brushless DC motor. This is also advantages of the switch reluctance motor. So it can be work with a two-phase or three-phase per generator. Okay, phase losses do not change the operation of the motor. Okay, once the phase sequence is changed, then the motor direction will be changes. Okay, if any phase sequence changes, the motor direction is changes. Okay, this is also advantage because if the sometimes by mistake if any phase sequence changes, if the motor is not rotating, then what will happen? The motor is going to be damages. Okay, even though motors should be rotate in the reverse direction, if the any by mistake any phase sequences changes. Okay, so also we can take advantage of this one if you want to rotate in reverse direction. For example, in vehicle applications, if you want to move the vehicle backward, so motor should be rotate in reverse direction. So by changing the phase sequence, the more we can change the speed of the direction of the, we can change the direction of the motor speed. So by changing the direction of the motor speed, we can move the vehicle from backward or forward direction or backward direction. Okay, that is also one of the main advantages. So this self-switch reluctance motor is a self-starting motor. So no need to use any additional arrangements. Okay. In the case of single phase induction motor, we have to use the capacitance because single phase induction motor is not a self-starting motor, but it is not for self-starting case we have to use the capacitors. Clear? So what we here no need. This is the switch reluctance motor is the self-starting motor. This is also advantage of the switch reluctance motor. Okay. So switch reluctance motors have less torque capacity and normally these motors noisy. It is having some drawbacks. It is having some disadvantages. Okay, so switch reluctance motors is having the less torque compared with the brushless DC motor because it is we are not even using any permanent magnets. So obviously the magnetization is very less. Okay, the torque is also very less. So while operating this motor at high speed, it creates a torque ripple. Okay, so whenever we can operate this motor in a high speed, but the torque is going to be repulsed, means some distortions will be occurring in the torque. So that is also one of the main drawback in the switch reluctance motors. And the noise of the switch reluctance motor is very high compared with the other motors. It uses an external rotor position sensor. So obviously in the brushless DC motor also we are using the position sensors, and in switch reluctance motor also we are using the position sensors. Okay, for identifying the position of the rotor circuit, for excitation of the stator coils, we need to use the rotor position sensors. We need to use the rotor position sensors. This is also drawback. Okay, by increasing the position, by using the additional equipments like sensors, again control circuit is will become a complexity. So all these are the drawbacks. Okay, the motor generates harmonics when it operates high speed. So to reduce this large size capacitors need to install. So this motor is generate the large amount of harmonics. Okay, when it is operated through the inverter. So in order to remove this harmonics, we need to design the, we need to use the capacitors. Okay, we need to use the filter. Okay, so to remove this or to reduce this harmonics, so this is also one of the drawbacks. Again, we need to use the filter. Okay, since the non-existence of the permanent magnets, the switch reluctance motor has to carry high input current to increase the necessity of converter kVA. So because here we are not using any magnets in the rotor circuit. So in order to get the high torque or high torque, so we need the motor should take the high current. The motor should receive the high current from the inverter. Okay, so this is also drawback. This is also drawback, because when if you the motor is taking the very high current from the inverter, so definitely we have to increase the ratings of the inverter circuit. Whatever we are using the components in the inverter, the ratings also we need to increase. So obviously it will increase the converter circuit cost. Obviously it will be increase the converter circuit cost. All these are having the drawbacks. Okay, applications. We can use the switch reluctance motors, textile machinery like towel looms, repair looms, okay, hand looms like this. We can use this switch reluctance motor in electric vehicles, okay, and machinery, testing machinery, mining machinery, conveyors, okay, ball mills, boring machines, coal crushers, and some mechanical presses like screw presses. Okay, all these machines we can use the switch reluctance motors. Okay, these are the switched reluctance motor drives. These are the switched reluctance motor drives. So let's see here. So what is the remaining topic? Solar and battery operated drives, operation and converter circuit. Only one topic is remaining in the 6th chapter. कितना टॉपिक्स बाकी है? कितना टॉपिक्स रिमेनिंग है? Okay, one topic is remaining in the IDC subject. Okay, we will complete in 1 or 2 lectures. Yes, you can leave the meeting.